So, like every other human, you are curious. You have seen the wonders of rechargeable batteries and can't seem to shake off the urge to know how these tiny powerhouses work. We find this understandable, would love to help you out with this dilemma. Before we go into how rechargeable batteries work, you will need to take a brief history lesson too. It will be fun, trust us. How rechargeable batteries came to be. Rechargeable batteries or secondary cell batteries are dated back to 1859 when the first lead-acid rechargeable battery mode was invented by Gaston Plate. This model was recharged by having an electrical current being run back into it. However, in 1899 another type of rechargeable battery which was made from nickel-cadmium was invented by Waldemar Junger. This rechargeable battery had a 2000 charge cycle and a 1.2 volt terminal voltage. A downside to this variation of the rechargeable battery was the fact it was toxic because of cadmium. The NiCad rechargeable battery was replaced by nickel metal hydride NiMH cells in 1967 and has featured in most devices that use AA or AAA batteries. Compared to nickel-cadmium, nickel metal hydride batteries cause less environmental damage. The lithium-ion rechargeable batteries took the limelight after being created in 1985, about 75 years after the research had begun. Lithium-ion rechargeable batteries were then commercialized in 1991. These rechargeable batteries are composed of a composite mix of chemicals. Lithium molecules are trapped within several compounds to make up the cathode, while its anode usually consists of several compounds and carbon or just graphite. The downside to lithium-ion rechargeable batteries is the fact they can be overcharged to the point of combustion, and this can be very dangerous. How do rechargeable batteries work? There are two types of batteries. These are primary cell batteries and secondary cell batteries. Primary cell batteries are disposable, alkaline batteries, while secondary cell batteries are rechargeable batteries. Rechargeable batteries are batteries that can have their energy capacity restored when an electric current is applied to them. Unlike alkaline batteries that can only be used once. Rechargeable batteries are regarded as electrochemical cells that can produce a certain amount of energy and can then be recharged when depleted by reversing their chemical process. Like we stated earlier, several types of rechargeable batteries have been developed over time, and they are 1. Lead-acid battery, which comprise a combination of lead and sulfuric acid. 2. NiCad nickel-cadmium battery. 3. NiMH nickel metal hydride battery. 4. Lithium-ion battery. 5. Lithium-ion polymer battery. To make things very clear for you, we will discuss how each type of rechargeable battery works. 1. Lead-acid batteries. Lead batteries comprise a flat lead negative electrode and a positive electrode, or plates, that are steeped in an electrolyte pool. The positive electrode is made up of lead dioxide while the negative electrode is made up of sponge lead. For most lead batteries, water is added. However, some low-maintenance lead-acid batteries come with excess electrolytes for the sole purpose of compensating for water loss during the battery's normal lifespan. These batteries are commended for their longevity. Lead-acid batteries require a minimum forming charge voltage of about 2.1 volts per cell from a battery charger before it can produce a voltage. Lead-acid batteries are known as storage batteries because they do not generate voltage independently, rather they store a charge from another source. The process of generating energy with lead-acid battery revolves around a sequence of chemical reactions. There are two states of chemical reaction, which are charging and discharging. You will need to pay attention to this next part. Charging a lead-acid battery. When a lead-acid battery is connected to a charger, the molecules of the sulfuric acid are broken down into two different ions, positive H+ and negative SO4 ions. The hydrogen ions exchange electrons with the cathode and are then converted to hydrogen. This hydrogen also reacts with the lead-2 sulfate in the cathode to become sulfuric acid and lead. In the same vein, electrons are exchanged between SO4 in the anode, which then becomes radical SO4. The SO4 has a chemical reaction with the lead-2 sulfate of the anode and lead peroxide, and sulfuric acid is created. The increase in the volume of the sulfuric acid brings about storage in energy and an increase in the cell's potential voltage. The discharging of a lead-acid battery involves the exact opposite of the chemical reaction that takes place when charging it. How do NiCad nickel-cadmium batteries work? NiCad batteries are made up of positive and negative electrode plates, electrolytes, separators, cell vent, and a cell container. The positive plates in NiCad batteries consist of a porous plaque that has had nickel hydroxide deposited on it, while the negative plate consists of the same porous plaque but with cadmium hydroxide deposited into it. Each plate has a nickel tab welded to it at the corner. These tabs are then welded to their respective terminal. Furthermore, an unbroken strip of porous plastic is used to separate these plates from one another. NiCad batteries make use of 30% potassium hydroxide added in distilled water as their electrolyte. How do you charge a NiCad batteries? During the process of charging NiCad batteries, there is a loss of oxygen from the negative plates, causing them to form metallic cadmium. Meanwhile, nickel hydroxide, which is the active material that makes up the positive plates, becomes highly oxidized. While a charging current is applied to a NiCad battery, the chemical reaction will continue until the negative plates are devoid of oxygen and only cadmium remains. The cells in NiCad batteries begin to emit gas towards the end of its charging cycle or when the cells have been overcharged. This emission of gas is as a result of the water in the electrolyte decomposing into hydrogen around the negative plates and hydrogen around the positive plates. The occurrence of gassing is determined by the voltage used in the charging process and the temperature at which the NiCad batteries are charged. The discharge of NiCad batteries involves the reversal of the charging process, where the oxygen from the positive plates are given up and then passed back to the negative plates. This chemical reaction is what brings about the conversion of chemical energy in NiCad batteries in electrical energy. How does a NiMH nickel metal hydride work? NiMH nickel metal hydride batteries are the same as the Li-ion batteries, including the chemical reactions involved. However, rather than using cadmium for its negative electrode, NiMH batteries make use of a hydrogen-absorbing alloy. How do lithium-ion batteries work? These batteries have been involved in a bit of controversy due to their tendency to burst into flame, which is why we need to use them with care. Lithium-ion cells come in a cylindrical shape covered in a metal outer shell. These metal casings which have pressure-sensitive vent holes. These metal castings are used because lithium-ion batteries are pressurized and the vents are there as a form of safety measure. Lithium-ion batteries consist of 3 thin sheets, positive and negative electrodes, and a separator, that have been compressed. These sheets are immersed in an inorganic solvent, ether, in most cases, which serves as the electrolyte. The separators in lithium-ion batteries are made of microperforated plastic which allows ions to pass through while separating the negative and positive electrodes. The positive electrodes are made of lithium cobalt while the negative electrode is made of cobalt. The process of charging lithium-ion batteries involves ions of lithium moving through the electrolyte to the negative electrode from the positive electrode and attaching to the carbon. On the other hand, while discharging, the lithium ions in lithium-ion batteries move back to the lithium cobalt from the battery's carbon. How does a lithium-ion polymer battery work? Lithium-ion polymer batteries are the same as the lithium-ion batteries, including the chemical reactions involved. The only difference between both types of batteries is that Li-ion polymer batteries use electrolytic gel-covered, micro-porous polymer as a separator rather than porous inert substances that have been covered in an electrolyte. Understanding how rechargeable batteries operate helps you appreciate the chemistry behind these inventions that have a big impact on our everyday lives. As you have learned in the process of watching this video, it is advisable that you do not overcharge your batteries, as doing so can cause a breakdown in their functionality and also be harmful to you. Please be advised that even though we have broken down how batteries function in chemical reactions, we do not recommend that you try to recreate these reactions by yourself. Chemicals can be very harmful, can lead to permanent injuries and even death. Also, do not attempt to strip down your batteries, as doing so can cause them to explode, thereby causing injuries. We hope this video has been useful in your quest to understand how rechargeable batteries work. Kindly click the subscribe button and turn on the notification icon, so you always know when we post a new video. For more rechargeable battery contents like this, visit our website at www.zimrechargeable.com.